Thank you for joining today's webinar on building a modern, scalable, and effective application security program. Today's webinar is hosted by Contrast Security, a signatory of the Cybersecurity Campus Board, and who are pioneers in enabling self-protecting software with security safeguards built directly into modern software. Last year, the Tech Accord announced a new partnership with the Global Forum on Cyber Expertise to strengthen cybersec capacity, building through the exchange of best practices. To further our commitment under that umbrella, we launched a series of webinars to increase the understanding of key cybersecurity topics, such as the ones you will hear today. Today's webinar is hosted by Jeff Williams, co-founder and CTO of Contrast Security, where he brings more than 20 years of cybersecurity and leadership experience as co-founder and CTO of Contrast. Previously, Jeff was co-founder and CEO of APPSEC Security, a successful and innovative application security consulting company acquired by Ernst & Young. We welcome you to share any questions you have today using the chat box located on the right of the screen, as there will be time at the end of the presentation to address questions. And now I'd like to introduce Jeff to take it away and kick off the webinar.
Thank you. Could you make me presenter so that I can share my slides?
Yeah, Jeff, I have you marked down as a presenter, so you should be able to share your slides.
Okay. It's, oh, here we go. Excellent. Thanks, everybody. So thanks for the nice introduction. I have spent the last 20 years trying to help companies build effective application security programs. I feel really fortunate to have worked on some of the world's most critical software, as well as hundreds of banking, healthcare, airline, mobile, even video game applications. So today I'm going to tell you that unfortunately we're losing the battle, but I'll also give you a roadmap for a program that works. So first, the bad news. Your applications are being attacked all the time. And if you don't have the data, then you're just not looking. As you can see in this chart, you can see your application has a 77% chance of being attacked with SQL injection attacks this month, and a 50% chance of being attacked with path traversal, and let's see, 38% of being attacked with XSS, and so on. Your chance of not being attacked this month at all, or 0. So look, if you didn't have any vulnerabilities at all, then these attacks wouldn't be a big deal. But the average application has 26.7 vulnerabilities. That's a staggering number. And can you imagine if an airplane, your airline had an average of 26.7 safety issues? Nobody would fly. But we happily use web applications for things like banking and healthcare and following the Kardashians and all sorts of stuff. As you probably can tell, I'm a little disappointed by all this. When I wrote the OWASP Top 10 in 2002, I thought that we would be solving some of these issues and raising the bar over time. Unfortunately, it's still basically the same things in the OWASP Top 10 that were there in 2002. So we're not in a particularly good place. Every day, software gets more complex, more connected, and more critical. And that's sort of the perfect storm for insecurity. Application security is already the #1 cause of breaches by a pretty wide margin. I'd say application security has thoroughly frustrated developers. They would say that security slows down their process with scanning and false positives and gates and manual steps and so on. And I think really that, while there is a security skills shortage, I don't think we're ever going to close that gap. I think we need to change the way we're thinking about it and change the way we do things. So it's not like we haven't tried stuff. I've been working in software security since the late 80s. I started on my first project was a Navy project that had a formal security model. That means it was a level B2 project from the old Orange Book, which if you haven't seen, you might be interested in. But that meant that we built a mathematical proof that demonstrated the security properties of our software. Unfortunately, formal methods dramatically limit the range of software you can possibly build. So it didn't effectively change the market, and software kept rocketing ahead. And we've seen over and over, we've tried things. We've tried maturity models. I was involved in building the system security engineering CMM back in the late 90s. And unfortunately, they don't work. They're great for consultants, but if your model has 200 activities in it and you do them all, you still might be producing insecure code because they're measuring process, not measuring the output of the process. We've tried things like public shaming through vulnerability disclosure and breach disclosure. Didn't really change anything. We're not going to hack our way secure. We're not going to scan our way secure. We're not going to put standards in place that solve the problem. Bottom line, sort of all these things that we've tried, if they were going to work, they would have worked by now. But unfortunately, application security is getting worse. I think of it as impossible economics. There's a huge gap between what the level of security that we need to produce and the level that we're currently able to produce with the limited amount of security experts, budget, and tools that are available in most organizations. And unless we change the economics, then nothing's ever going to get better. So I want to focus on how do we change those economics and what kind of program can we put in place that will get us at least back in line with the curve of software. Many people, so primarily security people, think that the solution is to slow things down. They think about security as if you were building a castle. They might passionately argue that we need to get better at building security requirements or doing security architecture or creating test plans. And I think the idea is, maybe if we can get software to just slow down and go back to the old way of doing security where you kind of lay everything out up front and then, build according to that plan, that we can force today's fast software development to be secure. But it won't work. Slow security doesn't work in a fast world. The car that we started out building, for example, changed to a helicopter and then to a jet while we were building it. And while it's flying around, it's being attacked by a novel attack that some Black Hat researcher just released. So we need fast security that can adapt to changing requirements quickly. There's nothing wrong with that. There's no reason that security can't adapt as fast as software and as fast as the threat. We can't work with everything locked in from the beginning. So we need to change that mindset and move to fast security. One of the biggest problems is that the tools that we use require human experts. To do security today, you need sort of all of these tools because they're all inaccurate. And so people run multiple different tools to try to cover up for the weaknesses in the other tools. It's a little like that story about the blind men describing an elephant. They make a ton of mistakes because they're only touching their piece of the elephant. And if you tried to take the descriptions from each of the blind men and put it together, you wouldn't get a picture of the elephant. You'd get some crazy picture of something that doesn't make sense. The problem is that none of these tools have all the information. They don't have all the context that they need to be accurate. Now, there's no reason that a single tool can't have access to the source code like a static analysis tool, and the libraries like a software composition analysis tool, and the HTTP traffic like a DAS scanner or a WAF, and the configuration files, and the backend connections, and the full data flow, control flow from inside the running application. There's no reason that we can't have a tool that has access to all those things. That really is the only way to be accurate. And accuracy is critically important because if you're not accurate, then you have to have experts involved to resolve the false negatives and the false positives. And experts don't scale. So we've got to change the way that works. So the question that comes up is, can DevOps help security? And when I look at it, I think about the problem that DevOps targeted. Things like poor quality, late, slow software, software that doesn't provide business value. And I think, wow, those are exactly the same problems that are plaguing security. Security is pretty poor quality. it's late, it's slow, and frankly, doesn't provide a lot of business value. So the solution that the DevOps community came up with was this DevOps approach, and it's had really fantastic results. And that's a topic for a whole other talk. But what I want to point out is that maybe DevSecOps adopting DevOps practices to transform the way that we do security could have some significant results. I would love to see results like organizations that are tackling their whole application portfolio, not just the criticals. What if we could reduce the number of vulnerabilities that makes it into prod by 80%? What if we could stop adding so much delay to the software pipeline and add zero time to the pipeline of software into production? Those are some of the kinds of results that I think DevSecOps can achieve. Now, DevSecOps isn't about shoving traditional security practices into DevOps. My friend Larry at Comcast would say that's putting DevOps lipstick on a traditional security pig. What we want to do here is we want to actually transform the work of security. And if you haven't read the Phoenix Project, you should. And I want you to think about how can we translate those ways, those 3 ways, into a way of transforming security work. Roughly, the first way is to establish workflow, and we need to establish security workflow. We can break security work up into small pieces and track it to completion, creating flow. The second way is creating instant feedback, and we can create instant security feedback. Hopefully we can get it right to the people that need it through the tools they're already using instead of delivering PDF files. And the third way is to create a culture of experimentation and learning. And we can create a security culture that gets everybody involved and focused on the right things to make sure that we deliver secure applications. So that's where this talk starts. This isn't a talk about DevOps. I'll give you a few recommended resources for exploring DevSecOps, but I'd say we're officially off track here. I don't care how you build your software. There's many ways to build software, high quality software. And security shouldn't really be in the business of telling development teams how to build or test or deploy their code. This talk focuses on outcomes that matter. So let's talk about that. Let's imagine that this box represents your application portfolio. And on the left here, we can see the application inventory. We've got some more critical apps up at the top, all the way down to the lunchroom cafeteria menu application way down here at the bottom. And I've broken it in 2 halves here. We've got the development security piece. This is our code hygiene. This is where we want to reduce vulnerabilities that we're delivering. And also operations, critically important to secure in operations. So let's talk about expectations. So you may remember Equifax. People sort of freaked out because they forgot to update a library. And I'm not saying it's not serious. It's a shame that people, including me, got hurt by that breach. But what folks are really expecting is you can see it in the outrage that happened after that breach. You can see people are expecting that your applications are always in compliance, that you have zero vulnerability backlog, that you're going to instantly remediate new vulnerabilities that are found. You'll instantly update to new versions of libraries when new vulnerabilities come out. And you'll continue to add new features. They also demand that, right? On the operations side, I think people expect you to detect all attacks. They expect that you'll have all the details of all the attacks, right down to the line of code. They'll expect you to stop those exploits from harming you. And they expect you to have an infinite amount of log detail so that you can absolutely figure out exactly what happened in case of a breach immediately. Well, as you can see, there's this massive disconnect between the reality of software and software security and how people perceive it. So I'm saying, sooner or later, people are going to find out that, we have huge vulnerability backlogs and we can't remediate vulnerabilities right away. And that's the gap that I want to try to target. So unfortunately, this is sort of a representation of what I think some of the best application security programs achieve. And I've talked to hundreds of big companies about this, but the vast majority of those only really do application security for their more critical applications. That's where they're doing SAST and DAST, they're doing IAST and other tools, they're running SCA, they're pen testing, but they're getting, sort of limited coverage over their portfolio, and frankly, over the space of security. Like, they're not getting super deep into security because it's hard. One pen test a year is not going to get you to a very high level of assurance. And on the operational side, most organizations don't have good visibility into what's going on in production, and we'll dig into that in a few minutes. But I just wanted to let you know this is kind of the gap and sort of the opportunities for improvement in application security is getting much better security and coverage over the application portfolio during development, and then expanding that protection so that we've got a good idea of what's going on in production. We know who's attacking us, we know what kind of attack vectors they're using, and get that visibility that we can't get from simple sort of WAF approach. So the rest of this talk is about building an APPSEC program that focuses on outcomes. So outcomes are the concrete things that your software factory actually delivers. And that software factory, it delivers software, of course, but it should also be delivering security. And I want you to think of security as basically an argument that your software is actually secure. If we can get that to a nice, clean argument that says, hey, we've got the right controls in place to match the threat for this application, we've got the evidence that those controls are properly implemented and effective, and we've got data from production about how our defenses are behaving in production, we got a nice argument that that an application is secure, and we can scale that across the portfolio. So I kind of want you to forget about how APPSEC programs, traditional APPSEC programs work, because that's obviously not working, and focus on all the waste that we have in application security today. We repeat a bunch of activities throughout the life cycle. So we figure out security at requirements time, and then again during design, and again during testing, and then again at pen test time, and so on. We test for things that aren't possible. So for instance, I've seen folks, scan for SQL injection in applications that aren't using a SQL database. That's crazy. Starting a pen test from scratch every single year is crazy. Not relying on the automated tests that we know are good during our pen test is also crazy. There's a ton of wasted work there. So for this approach, we're not going to mandate a bunch of processes and an organization structure that you have to implement. There are many ways to achieve these outcomes. And frankly, you can achieve them any way you want. I encourage you to experiment with these. I think we need better experimentation in application security to try new things. We can't continue to look at the failed practices of the past. And this is important, is I don't want you to think about trying to achieve everything all at once. I want you to think about taking small bites. This approach is an iterative model. So we're going to focus on one piece, and we're going to get good at it, and then we're going to expand the model over time, the things that make the most difference. All right, so let's jump into it. The first outcome is inventory. And the first step in figuring out how to secure first step in securing anything is figuring out what you're securing. You got to get your arms around the problem. So most organizations have really no idea what code is running where. Most rely on kind of manual processes for keeping their application inventory up to date. And they miss a lot of apps, they miss a lot of pieces, and they don't gather all the details that they really need. So I encourage you to figure out how to get a good inventory of all your applications. You need to know all the code that's running on your servers, even back through the development and test process, That inventory needs to be continuously up to date. And you're going to want to know the version numbers of all the code that's running, whether, if it's your custom code, then you want to know what build you're working on. If, what branch is the code that's actually running somewhere. If it's library code or framework code, then you want to know the exact version of that code wherever it's running, because, tomorrow, some black hat researcher is going to release some new vulnerability in some library, or a new class of vulnerabilities that affects your custom code. And you're going to have to be able to very quickly find those problems and take action. So you want to know, you shouldn't have to go scan everything. You should know exactly what software is running everywhere. I encourage you to focus on automating this inventory process. Not scanning. I like the idea of self-reporting. So you enable your environments to self-report the code that's running there. A very powerful way to keep your application inventory completely up to date with the exact versions. Imagine if all your software was sort of reporting its own bill of materials, and it can give you some context. That's a powerful way of achieving this. But remember, don't worry about going crazy with this in your first iteration. In your first iteration, just write down the applications that you care about most. You can put it in, make a database somewhere. You're going to build this over time and develop it. And consider what metadata you want to try to capture. You probably at least want some contact information about who's working on that project, who to call in case of emergency, that kind of thing. Okay, so that's inventory. The second outcome that we want to focus on is security architecture. And people are always asking, sort of, is it secure? But they skip right over that question of, what do you mean by secure? And I think we need to be much more clear about what our security expectations are. This is what we're going to test against. So we've got to be really clear about what we expect out of security. And security architecture is that way of expressing that. Some people might call it a threat model. Some people might call it requirements. I think it's useful to think of it as, sort of the defense strategies that you're going to use against the threats that you have. It would capture things like, what's your plan to handle SQL injection? How are you going to handle unsafe deserialization or clickjacking? Or any threat that matters to your enterprise? You need to have a strategy for approaching that. And again, you don't have to get bogged down in everything. I want you to focus on your next most critical risk. It's way more important that you get SQL injection thoroughly solved before you go worrying about, something like log injection or the use of system out print line or some, trivial kind of risk. Over time, this process is how you're going to get to a really strong enterprise security architecture. And that this leads directly into the next outcome that we're looking for, which is verified defenses. I think that's what people expect, is that folks would actually verify the defenses that they think they're using. So here we're looking for measuring your actual security against the expected security that we defined in the last outcome. So this is actually, I think, one of the most important outcomes, because here we're measuring the actual software. We're not measuring the people or the process or the tools that made the software. We're going to measure the actual software to see if these defenses actually work. Now, a lot of organizations think that the goal here is to run some scanner to verify security, or maybe multiple scanners. I think that's actually ridiculous and a little bit wasteful. I think what you want to do is focus on making sure that each of your defenses is accurately and effectively tested. So for each of the threats that you have, you've probably identified a defense strategy. Like, for instance, for clickjacking, we may choose the use of an appropriate X-frame options header. Now, we want to verify that we've properly applied the X-frame options header to every outgoing HTTP response. So how are we going to test that? Well, maybe in our test environment, we can proxy all the traffic that comes back out of the web application and verify that that header has been properly set. That's a strong way to get really good coverage over that clickjacking protection without having to do any extra work. That tool could instantly notify if there's ever a clickjacking header that's not configured properly. Similarly with SQL injection, maybe we decide we're going to use prepared statements everywhere for SQL injection. Now, that's not 100% perfect, but it's a good step forward. We could verify that with IAST, particularly good at data flow. So IAST can focus on those queries that are really potentially vulnerable to SQL injection and automatically, passively verify that all of our queries are being done in a safe way. So if you continue to automate the most important defenses, you'll get stronger and stronger over time, and you'll continue to reduce the set of things that you need to do manual testing on, right? If you've done a great job verifying that you've got appropriate SQL injection protections in place, you've got great code coverage and great accuracy, then you can confidently tell the pen testers to focus on interesting, harder things like authentication and access control. That brings us to the fourth outcome, runtime protection. So remember, we talked about code hygiene. We want to make sure that we're producing code that's strong and resilient. People call that shifting left, although that's kind of, I think, a trivial way to think about it. We need security in operations as well. It's not just DevSec, it's also SecOps. So we need to make sure we get security into operations. And like I said before, most organizations have really limited visibility into what's going on at the application layer. I think everybody should know that exactly who's attacking them. They should know the attack vectors they're using, which systems are being targeted, and they should have the capability to stop vulnerabilities from being exploited. And if there is an attack, they should have an infrastructure in place that allows them to respond to those attacks, even novel attacks. So that infrastructure is what I'm talking about in this runtime protection outcome. And I want you to just imagine the telemetry that comes off of this. All the attack details, you can see exactly what the bad guys are trying to do. That's such a motivating bunch of data for sharing with the development teams and the other teams in your organization to show them, hey, look, security is really serious. We're getting attacked. Imagine how much more seriously they'll take vulnerability reports if they know that they're being attacked. Okay, we're getting there. We've got inventory. We've defined what our security means. We've verified the defenses, and we've talked about runtime protection. The fifth outcome is analytics. And I think it's important to get the real facts about exactly how well your application security program is doing. People often ask what metrics they should be using for application security. Well, to me, the most important metrics are against the outcomes that you care about. So in other words, the 6 outcomes in this model. Fortunately, they're all pretty concrete and they're pretty easy to measure. So here's the 6. We've got one more to go after this. But you can see that each of these is relatively easy to measure. You can imagine measuring an APPSEC plan from just sort of ad hoc, undirected plan, all the way to a very structured, organized plan. Application inventory, some people don't have any, all their apps are kind of untracked, or to something that's automatic and continuous and complete. You can imagine security architecture that doesn't think ahead about threats and doesn't deal with the appropriate dangers, and one that's proactive, that's ahead of the game, and so on. It's actually, we've got a little checklist here that you can use to kind of score yourself. It's not, 200 practices that you have to go assess with interviews. These are actually pretty concrete and should be easy to measure. But you can imagine calculating yourself a score based on each of these 6 outcomes that we're trying to achieve, and give yourself sort of an overall score against the whole model. You might You might picture that with spider diagram so that you can see kind of where you stand, and maybe you can compare yourself against industry averages here. But that brings us to the last outcome that really matters. This is your APPSEC plan. And if you have great analytics, then you should be able to create a great APPSEC plan because you'll know exactly where you're weak. And I think whereas other models might tell you, you know, if you're weak in an area, then here's the exact activities you got to go do. I think that's actually really dangerous. I think a lot of the activities don't apply to many software shops. There's, like I said, there's a lot of ways to build software. So this plan, I think what you want to do is, identify some significant improvements that you want to make in your program against the plan. Maybe you want to expand your inventory coverage so that you're getting all the apps, or maybe you want to add protection at runtime. So you really want to focus on expanding your operational side of security. Maybe you've got a ton of legacy apps that you don't want to go fix, and so you want to add protection there. There's a lot of ways to slice this, but I think it's always custom and not very difficult to think about. So ultimately, I want you to not get overwhelmed. You can start a great application security program today. Think about how long it would take you to just write down a list of your most important applications. You know it'll expand over time, but let's start the process. What's your most serious risk? Is it SQL injection? Is it command injection? Is it some vulnerable library like Struts or Spring or something? Focus on what you're going to do about that risk and make sure that you hit all the outcomes in this model for that particular risk. That's it. Maybe you could add, maybe you can get a lot of coverage with some simple moves here by maybe adding IaaS to your development process so that you can more easily find vulnerabilities, or maybe you add RASP in production to try to limit the amount of bad things that attackers can actually accomplish. That's the goal of this model. We've tried to keep it really simple so you can get your head around it. And I encourage you to reach out to us with questions, and we're happy to come talk to you about how you can get started with a sort of a simple, effective approach to application security. What we've seen with organizations is that it's working. We've worked with a bunch of different companies on this kind of simple program and getting them focused on what really matters. And we've had some tremendous results. You can see on the left here, a top software company was able to expand their portfolio coverage to 1,200 applications in less than a year. They've worked off the entire vulnerability backlog for those 1,200 applications, and they've achieved the place I call the new normal. It's when new vulnerabilities get introduced, and they're introducing, it's actually about one a month per application is a pretty good average. But they almost instantly fix those vulnerabilities and go right back to clean. We've seen big reductions in pen testing costs. When you start tracking what you're actually verifying with automation and doing it well, then the amount of pen testing you need to do starts being reduced. And we've encouraged companies to take the output from their pen test and turn it into software so that they then continuously check for those kinds of flaws, so that pen testing isn't just finding the same problems over and over every year. Pen testing is the means by which you get stronger. We've seen massive increases in software speed. When you start pulling out the checks and the gates and the blocks out of your software development pipeline, getting rid of the scans that take hours or days to run, you can massively accelerate the software process. In fact, I encourage companies, if they've got a great argument that says our application's secure, it's got the right defenses, it's been thoroughly tested, and it's covered all of the application, then you're ready to go into production at whatever velocity you want to go. And that's sort of a policy change that you can make to encourage people to do software security. And then the last thing is, we've enabled many companies to see what's going on at the application layer. And it's been fascinating to see, what happens when you turn on the lights and see that applications are being attacked all the time. Most companies just don't have visibility into it, either because they don't have any sensors or their sensor is a WAF and it's so noisy that it's impossible to determine what's real. So these are just some of the kinds of outcomes from this program. And I encourage you to think about reworking your APPSEC program to focus not on just implementing processes, but on actually making a concrete difference in the outcomes that matter. So that's the talk. I've got time for some questions here, so please feel free to ask me anything.
Thanks, Jeff. I think we have a couple questions already, and then again, if people want to get any questions, feel free to put them into the chat box on the right hand of your screen. I think the first question is there still a need for expert penetration testing?
Oh, that's a great question, and I covered it a little bit, but I want to reemphasize this point because it really is important. So I spent many years pen testing and code reviewing, and I think it's a really valuable activity. I found tons of really interesting, complicated vulnerabilities, but most of my time was spent searching for pretty obvious vulnerabilities, things that we should be able to automate today. And so I want you to change the way that pen testing works as part of your program. That means using automation that's good and accurate, that you trust, and that means sort of choosing your technology selectively to verify the things that it's really good at, and then using pen testing to fill the gap, to verify those parts of your expected security model that you can't automate yet. That's where you use pen testers. And hopefully your pen testers won't deliver just a text write-up, but they'll actually figure out how to write an automated rule that will then verify that thing for you forever. So what you're doing is, over time, your pen testers are driving the improvement of your application security test part of your pipeline. That's what raises the bar over time. And next year, when the same pen testers come back to test the application, they'll be starting from a higher level.
I have a question from in the chat box saying we still want to build security in with shift left to developers so they write better code in spite of all the tool set at various levels. Your thoughts on this?
Yeah, so shift left is interesting. I mean, it's a good slogan, but it's really kind of a trivial conception of, I think, how application security ought to work. So I think the key to effectively shifting left is to not take legacy security tools like static analysis and dynamic analysis tools and just dump them onto developers. I call that shitting left, because those developers aren't really trained or qualified to use those tools. They're not designed for them. We need to give developers feedback that they can actually use. That means it's got to be super accurate. That's what will allow them to trust the tool and not waste their time chasing down false positives and so on. So I think, to me, the key to shifting left is kind of instant, accurate feedback directly to developers through the tools that they're already using. And the goal is, let's help them commit clean code. That way you'll save all the work that happens downstream, all that work, triaging vulnerabilities, deduping them, risk ranking them, tracking them. If they can just fix these vulnerabilities in stride, then the cost is dramatically less. But I will say this, the cost of security vulnerabilities, it's not a straight line that goes up over the course of the SDLC. It's really bumpy. I'd say, about 30 minutes after the developer stops working on a piece of code, the cost goes up dramatically of any vulnerabilities in that code, because they go on, they start working on something else, and for them to reopen that section of code and start working on it again is going to be really expensive.
Another question coming in. What tools do you recommend for DevSecOps?
Yeah, so I mean, the obvious tools that, well, you know, from my perspective, the obvious tools are things like IAST and RASP, because they are more accurate and they give instant feedback. They're much more compatible with DevSecOps. I think there are a few open source tools that can be helpful. I think you know, tools like OWASP dependency check, although it's more of a scanner, it's free and it does the job. I think I like retire.js for old JavaScript libraries, things like that. But I don't think necessarily that you need you know, a bunch of different tools. I think the important thing in DevSecOps is leveraging the tools that your development project are already using. So you shouldn't create a separate infrastructure for security bugs. They should be filed in, you know, you should get a Slack alert. You should get a notification right in your IDE. You should get a Jira ticket. You should fail the build. It should all be part of the same tool suite that you're already using.
Another question coming in. Should an interactive application security testing be built as part of language compiler or interpreter?
Oh, that's interesting. So it is possible to do IAST as part of the compiler. So, you know, sort of you'd weave in the extra security sensors as you compile the code, and then when it runs, the sensors are there. But that it either requires code changes or it requires an extra compile step. So what we found is that the easiest way to deploy IAST is by doing runtime instrumentation. That means as the platform starts up and it starts loading code, that's the point when you instrument that code. So as it comes from disk into memory, you add in the security sensors as the code loads, and then the fully instrumented application runs there. That just seems like a more standard, easier way to deploy IAST everywhere. And RASP, for that matter, works the same way.
There are no more questions. Thank you so much, Jeff, and everyone else in attendance for joining the webinar on application security. And please be on the lookout for the future cybersecurity technical webinars we have coming both in September, and I think we might have 2 in October, so be on the lookout for that. But thanks again, Jeff, and everybody else. Have a good day.